Welcome, everyone, to another screencast with Mr. Swan. On today's screencast, we'll be talking about asteroids, comets, and meteors, and I have a fun picture or clip to kind of show you, and we'll talk all about it. Afterwards, I have a little activity for you to do. It's a moon survival activity where you'll get about 15 items or so, and your goal is to rank them on their order of most important to least important on if you got lost on the moon. They gave that same activity to a bunch of NASA astronauts and people who also work there, and they actually put together the answer key. So this answer key and explanations do not come from me, but from people who actually work on NASA about what is a useful object on the moon and what is not. To start off, let's start off with some good news. My daughter's actually feeling really good today. The bad news is I am not, so I'm still at home at least for a little while longer. Um, Also, this is a good opportunity to put your phones in the phone holder. That is not a request. That is a class requirement. So if the sub needs to pause this video for people to go ahead and do that, feel free to do so. Otherwise, let's continue on and let's begin. The last time that we were here together, I showed you this on your reference table, which hopefully you have already pulled on out because you'll need that again today. If the video needs to be paused for people to pull that out, feel free to go ahead and do so. And we kind of talked about the different planets like a little bit. We talked about the terrestrial planets. We talked about some gas giants, which are down over into here. And today we're actually going to be talking about what's in the middle of them, like what's right in the middle in between. And that is an asteroid belt. What is an asteroid? Asteroids are ginormous rocky chunks that orbit the sun in a large asteroid belt located between the orbits of Mars and Jupiter. So make sure you know that the orbits of that asteroid belt are between Mars and Jupiter. That's going to be the boundary between the terrestrial planets and the gas giants. Asteroids can come in a lot of different sizes, can be up to incredibly long, like the 1,000 kilometers. Um, they can be huge asteroids. The picture I have for you over here, this is the asteroid Vesta. It's considered to be one of our brightest asteroids in our night sky. It is second in size and diameter at about 525 kilometers. That's pushing like 300 something miles. So that's like from Burn Hills, maybe going down to like New York City and maybe back. It's a large chunk of rock, and really the rock that makes up the asteroids is the exact same as the rock that makes up Earth. So the rare materials, the rare mining stuff like that we find here, you can actually also find over into there. One of the asteroids that is even bigger is Ceres, um, almost about twice the size, and technically, because of our new classifications of dwarf planets, it's also a dwarf planet. So there's actually is a dwarf planet rolling around in that asteroid belt. Some common misconceptions of asteroid belts usually come from like TV movies, and I figured let's go ahead and take a look at one of those. I click ahead a little bit too much, but sometimes like when you think of an asteroid belt, um, this is what you imagine, right? Like on TV or maybe a sci-fi movie, it shows like a spaceship kind of flying through that. Star Wars had a great asteroid kind of flying to avoid the Empire kind of thing in their movies, and then like it makes for good drama, right? The asteroids are colliding with each other, creating smaller ones and splintering rock. That's what it shows on like sci-fi TV, but that's not exactly what it looks like in real life. And what it looks like in real life is not as exciting. It looks like this slide. This is an actual model of the asteroids in our asteroid belt, and kind of talk about our four interior terrestrial planets of like Mercury, Venus, Earth, and Mars, and then all this is our asteroid belt. And if you wanted to, let's say we have a spaceship and we leave Earth, and you just pick a random direction to fly through. Either maybe this way, or maybe you fly off in the general down in this direction, or maybe the general in this direction. It is almost a guarantee that you would fly in a straight line and not hit an asteroid. In the movies, they're really close together, but in real life, these are hundreds of thousands of miles apart. So you don't usually see them very much. There are other asteroids around. Like there's groups of asteroids that kind of go in the orbital path of Jupiter. If you've ever had a summer day where sometimes people talk about like taking a look at meteor showers and things like that, that's a lot of times where like these two groups actually come from. One of them famously happens over in the end of August, and let's go take a look of like how they actually found those. It's not such an easy process. And pretty much, I guess, it starts from amateurs. These are people who want to kind of go look up into space, and they kind of use the telescopes to go for it. There's no um, official group really who's looking in the sky for asteroids, and like that's maybe a bit of a concern because you're like, well, what happens if one of them was going to come in and hit the Earth? And this model is trying to show, right? That has like the couple of inner planets, and there's Earth spinning around right around in this range. And every once in a while, it highlights a whole bunch of asteroids like on there, and it shows them in white. And it's hard to find asteroids because you can't look through the sun to see them. So you always have to look away from the sun and during nighttime to actually go ahead and do so. And over the years, we found like a whole bunch. In this case, it's like 1980. There's about pushing about 9,000 or so, and we won't watch the whole video, but I'll jump ahead a little bit. In 85, you're up to like 12,000. So they're finding like a couple thousand or so per year. But time is going on, and there's better telescopes than there used to be, and you can start to find more asteroids. And we're actually trying to keep track of them and actually try to map them, which is pretty neat. And it continues on. So now you're pushing about the year 2000. We're getting like 40,000 or so, and it's kind of jumped towards a little bit more towards the end. And they're finding just extreme numbers now. More telescopes, more people looking, better equipment, better technology, and all of a sudden we can find just an obscene amount of asteroids actually going up there. And now it's hitting up into the 600,000s, and there's definitely more than that. This video stops at 2015, but we still continuously find them. So that's like a lot of asteroids. So some questions usually that come from this is, well, why doesn't it look like the Star Wars movie? Like, why don't they actually kind of collide together? And the answer is they've already done so. Our solar system has been around for about 4.6 billion years. If those asteroids were really going to collide with other ones, they probably already had time to do so and would have done it. Another neat thing is like, well, why didn't all these asteroids really, if it's all just rock, how come they couldn't come together and eventually form like a new planet? Like just like another Earth or something like that out here. And the answer for that is this one right over here in the top. And it's Jupiter. Jupiter messed it all up, and we'll kind of go back and take a look at why that happened. What Jupiter does is, because since Jupiter has such an intense size and intense mass, intense gravity, it actually flings the asteroids around as it orbits around the sun. And it creates these like three pockets of asteroids. You can see like one here towards the top, one here towards the bottom, and one here on the opposite side of where Jupiter actually is in its orbit. And that's pretty much the reason. Like those asteroids can't really ever form a planet because Jupiter's gravity will not allow it. Which I always like just to see how like powerful really Jupiter is and what it kind of does. So I mean, it would be nicer if they were like more exciting, like a little bit. But like that's pretty much asteroids in a nutshell. And there's not really too much really to talk about except that a long time ago, not pushing by 1 week, I said, well, why do like would you go to Mars? And the answer is, some people said, yeah, maybe I consider it. Like why? Um, some other people are like, no, I would not. But like another question is, why Mars? Why would all these companies, in essence, private companies, spend tens of $1 million making rockets and failing, and trying again and failing and trying again and getting to a point where they're kind of getting to work, why would they go for Mars? And because there's no return on investment from Mars, like, that's a lot of money to spend billions of dollars in just trial and error rocket technology. There's no return on investment. So the real reason is, if you take a look at that one of those maps where it has, like, like the sun, and then you have those, like, you have Mercury, right, and then you have Venus, and then you have Earth, and then you have Mars, and then you have the asteroid belt, and that's what they're going for. Is that we're not going to go this direction. They're going this direction. Mars would be like a little stopover until they get an asteroid and bring it back. And so I said before, like, asteroids are the same thing that Earth is. It's the same metals, the same, pretty much the same material, which means that if it has the same metals on an asteroid, that's saying like gold and silver and platinum and nickel and iron. They're all right there, and you don't have to dig down in the earth to get it. You can just go on over there, grab a chunk of one, or maybe even a tiny one, and then kind of bring it back, and then you can mine it um, a lot easier and technically a lot safer. So how much is that worth? Well, one asteroid is thought to have roughly about $1 trillion in value of metals inside. So that's not millions, billions. That is trillions. That's a big deal. And so then you're like, well, is this really realistic? Is this really going to happen? And or some people are like, oh well, it probably won't. But usually, before, when people like going up into space, a lot of countries, they sign these ginormous treaties, and pretty much the before it said that anything that you find in space, anything that you really come across, really should be shared with everybody in the world, and pretty much every country signs up on for this. And I mean, it's not exactly a perfect example, but a really close example is GPS. GPS is actually roughly made pretty much in America by the United States Air Force, and every country in the world is actually allowed to use it. Um, but lately, the United States Congress actually got together and they made a little amendment for that. They said that all that is still true. If anything is found up in space, it would be shared with everybody, except if it's a private company. A private company can keep whatever they find. And so you might say, like, well, is that? I mean, I guess that'd be my big thing. Like, why would they do that if it wasn't a realistic option, right? Also, last, because I can, this asteroid Vesta actually has a thing called snowman craters. Snowman craters look like this. One's right there. One's right there. One's right there. It's a whole bunch of impacts that makes it look like a little snowman. Who doesn't love that? Next, going on over to comets. Comets are a little bit different than asteroids. They're composed of rock as well, but just like maybe a little bit more ice in there as well. A very common nickname is the dirty snowball. And so that dirty snowball continues to orbit around the sun, except comets do a little thing that's a little bit different. They get too close. And just like when you get too close to like a, let's say, campfire or something like that, it gets hotter. When you get too close to the sun, it gets hotter as well. And all those ions from the sun, all that radiation, that heat, comes off, and it starts to vaporize a little bit of the comet. So this would be the pretty much the main part of the comet would be right about here, and then the sun in this photo would be down on the bottom. So the sun would be here, and those rays from the sun come up, they hit the comet, they vaporize just a little bit, and they cause a tail to form. In this case, it has like two tails. Um, and the neat part is, if you wanted like a really good picture of a comet, you have to wait for the tail to get, or I should say, you have to wait for the comet to get closer to the sun, because that means it will vaporize even more, and the tail will get longer and bigger. So this comet um, is called Hale-Bopp, and let's move this right out of the way. Comet Hale-Bopp, you've never got to see it in person, and you never will. Last appeared about 1997, and is one of the most famous ones that you're ever going to find, mostly because it was really, really close to the Earth, all just sheer luck. Really, really bright, and it gave us some of the best comet pictures that we're probably ever going to get. The next time it's coming around is roughly in about the year 4,380. So pushing like 2,000 plus years from now. It's it's going to be a while. And to help you understand about how those comets move around, I made this wonderful picture. I hope you enjoy. And we start with our comet right here down towards the bottom. As the comets move around in their orbit, they don't always have a tail. So when the comet is away from the sun, in this case made by that little star right there, there's no tail to be had. And those comets' orbits can be extremely, extremely long. As I said, Hale-Bopp was about 2,000 or so years. That goes way out past Pluto, and then works its way back around in there. And since it orbits our sun, it's part of our solar system. So sooner or later, it eventually will start that orbit, and it will start to go back around. And then as it gets closer and closer to the sun, sooner or later the tail will start to form. And that's my little picture of a tail right there. I know it's beautiful. As it continues to go on, the tail will get a little bit longer, and it'll stay longer as it's closest to the sun at its max point. And then as it leaves, the tail will get shorter again. So some things to note: the tail is always going to be pushed away from the sun, always. So that means like if you had Earth right here in its orbit, and you wanted to take a photo of that comet, it's not. When the comet, let's say, is over here, that's not going to be a really good photo because you can't get a picture of the tail. So to get a photo of the comet with a really nice tail is hard. Everything has to line up really, really perfectly. There was a comet that came past, I think, about 2 years ago. It was only in our orbit just for a few days. That I think that you could actually really see it, and then it's gone. And then every time that comet orbits around, it's a little bit smaller the next time because it's getting vaporized. And eventually, the last of the comet that can be vaporized will be, and then it won't be a comet anymore. It will just be a chunk of rock floating around in space. Speaking of chunks of rocks floating around in space, sometimes those chunks of rocks get close enough to us that Earth's gravity draws them on in. And then what happens next is that as the rock is traveling through the air, it's compressing the air, and then it gets hotter, and then eventually it will light on fire. So meteors are rocky chunks that get pulled into the Earth by gravity. Most burn up in the atmosphere by compressing the air, seeing the ground as what we call shooting stars. Some meteors, when big enough, are able to hit the ground. When it hits the ground, we call those meteorites. And then usually the evidence we see from that is just ginormous craters. This picture is not a single shot photo. This is a whole bunch of pictures of meteors and shooting stars going through the sky, and then they Photoshop each one, and then they all stitch it together as one photo. To go find a nice meteor shower, I mean, August is right around mid-August is a good time to go do it. And um, what to do, really, to kind of go outside, make sure it's really dark, and give your eyes roughly about 20 or so minutes to really adjust the night sky, and you'll be start seeing like more stars and things like that. And eventually, after a while, you will see like little flashes of light. Now you might be saying to yourself, like, does this happen often? Like, are you worried about a meteor coming in and hitting you on the head as you're walking outside, doing the mile for gym class? And the answer is probably not. The meteor will probably not hit you. There's never been a recorded case of a person being hit by a meteor before, straight on, or even being killed by one. There's one case ever where they believe one meteor went in um, a woman's window, and then it bounced off the table and hit her in the arm. That's about as much as anybody can find about a meteor um, hurting somebody. So it'd be incredibly, incredibly uncommon. And then you'll say, well, how many are there? Like when you look up the night sky, do you see like meteors kind of coming down and raining down? The answer is, well, no, probably not. The sunlight is too big, or I should say too bright. And at nighttime, it's a dark rock on a dark background. You're just not really going to see it. And most of them get burned up. And the answer is we get hit by roughly about 2,000 to 5,000 a day. 2,000 to 5,000 a day, which is, I think, pretty neat. So if you wanted to walk outside, can you go find them on the ground? And the answer is yes, but it's really, really hard, because how could you tell the difference between like a meteorite and just like a regular rock on the ground? And the answer is you probably can't. Plus, our world is about 2/3 covered with water, so most of them land in the ocean. So like it's really kind of hard to get your hands on some meteorites. So where could you go? Like how could you find them? Like they're in demand for sure. People want those meteorites. You have collectors, you have science teachers who go on eBay and go buy them, like myself. Museums have them and really want them. Where could you go to go find them? Well, Burn Hills is probably not the best place because if one fell like outside, I'm not sure it would really be able to tell the difference between just a regular rock on the ground and a meteorite, just by the how they look. So one of the best places to go take a look at is Antarctica. Antarctica is covered mostly by a ginormous ice sheet. It's pushing like a mile thick. It takes just millennia to build. It builds like a couple millimeters per year, and so it's just ice, like it's just a mile thick of ice. So if you're walking around out there on this like mile thick of ice, and you see this random rock, well, that's probably a meteorite. And here's another picture of one. So when I talk about that, it's always ice. It's always ice. And so that's how they go find them. So that's one of the best places to actually go find them. A desert is also a really good spot to go to try to go find them, except that you have an issue with sand movement. So eventually, over time, sand grains kind of move, and eventually, then they'll start to descend down in the sand, and then they're lost. So that's how people actually like to go ahead and find them. I thought you might like to go see a one of the most famous meteorites. This one was actually found by a farmer actually on the field. It's ginormously huge, and it's incredibly valuable. And pretty much what they do is they cut off like little tiny little thin sections of it, and then mail it out. But it has like this gem and solid metal design into it, which I always thought looked really nice. So meteorites, pretty sweet kind of things. Um, do wishes work for shooting stars? Scientifically unproven at this moment. So it's hard to get some of these things on camera, or even for video. But with the advent of dash cams, which are tiny little cameras you put on the front of your car to go help fight insurance fraud, we do actually happen to have a couple videos of meteorites now. So this one happened over in Russia. And I'll play that for you one more time. This one would have to be a very big meteorite to cause like that kind of explosion. And it really was an explosion. People who were underneath it reported that their windows broke when it finally broke. But that's the good news is um, they burn up. And the reason why they burn up is because they're traveling through our atmosphere. And our atmosphere, even air feels like it's a whole, like just nothing, but it actually does have mass. And if you take something that has a bunch of mass and you cram it together, you will generate heat. And so that's why they actually generate heat. So a common misconception is that it's friction that burns them up. It's not friction, it's actually compressed. It's really compression of air that does that. And has a meteorite ever done anything for us? And the answer is, well, yes. So this is and you can actually go see them. This is probably the most famous meteor crater maybe in America. It's called Meteor Crater, and it happens to be over in Arizona. Sense of scale, this little building right here is not as big as our school, but it's pretty close. It's a lot of like research centers. And then this is a generous parking lot, right? And then that's a road right down over into here, and that is Meteor Crater. You're gonna walk all the way right around it. It takes about like 3 miles or so. I think, to go all the way around it. I did that a long, long time ago. And that's me walking around Meteor Crater. This is actually from my geology classes back when I was in college. And so, like, what do we do there? What do we study there? Well, the neat part is, it can be used for like a lot of different purposes. Um, Number one is trying to figure out like the size of these meteorites that eventually kind of come right in. And they're never as big as the hole, so it's actually much smaller. So this one would probably be roughly maybe about something like this. It's like a quarter of the size or so. And then it hits so hard in the ground, it vaporizes. So like vaporizes, you probably heard that word, but I mean, I think it's nice to kind of go over it just a little bit. Vaporization means that something got so hot that it, in essence, turned into a gas, or even possible plasma, right? Like the atoms, like the electron shells and things like that, just couldn't even hold on to each other anymore, and were just broken up into like little pieces of what they are. So that meteorite that hit there is gone. It's totally been vaporized. You can't find it anymore. And because Arizona is such a dry climate, the that crater is still there. Like 10,000 years from now in the future, it probably will still be there because it's so dry that all the rain, all the like the animals, vegetation, things like that should have all kind of maybe flattened this out by now. It's kind of a pristine area in that regard, so there it stays. Some things that it was actually used for, astronauts actually would get their suits on, start at the top, and they had to go climb all the way down in there and then climb all the way back on out. And the reason why is that this landscape kind of simulates the craters that you would find on the moon, and so they could kind of practice going up and down craters when they were going for their first moon landings. And now it's like a science research center, and also like a really nice kind of touristy destination. Speaking of touristy destinations, in our last, pretty much one of our last slides that we'll do today, radio telescopes, and we'll talk a little bit more about these when we start doing electromagnetic energy. But these telescopes are um, massive and sometimes different than what people imagine. Sometimes when you think telescope, like they think has like the glass eyepiece, and you're looking for visible light. But these are radio telescopes. They're looking for radio waves, the same types of waves that kind of carry information when you listen to the radio, like in your car. And then this one is called the Very Large Array. I think they tried to actually give it a name, but I select the Very Large Array. And it has all these satellite dishes. They're ginormously huge, and then there kind of sits out and roughly in the middle of the desert. I always really enjoyed their security system, um, which is some sticks in the ground with some wire kind of wrapped right around them. I always thought that was kind of funny. But these things are very, very big, and to give you a sense of scale on that, you can go visit them, and tourists too. You might be saying like, well, what are they there for? Like, why would you ever want to go visit these places? And this is, if we're looking for a spot to go listen for aliens, this is what they're listening to, and this is where people are actually going. The more radio telescopes you have, the farther apart they are, the more and better and farther distance of signals you can actually get out in space. And so you can kind of, I mean, you can go walk around, and they're listening for signals in space. And what does that sound like? It sounds like static. It just sounds like static, like that hissing noise on old TV sets. So, but what does it look like? Looks like sometimes like one of these, and I'll blow this up for you a little bit. This is called the wow signal. And pretty much like every time it picks up something, it assigns it like a number or eventually into a letter based on intensity. And pretty much there was like this string once, like right here, of very intense signal, and it lasted like 70 seconds or so. And then when one of the researchers was going through the data and saw it, he just happened to write the word like wow like right underneath it, and then it became known as the wow signal. We've only seen that once. We've never seen that ever again. It happened decades ago now, so no one really exactly knows what it is or how it could have come here. But that is where we stand today on these things. They have found there was one time where they were actually getting a repeating signal. Repeating signal is big. Like that's the one you're really going for. Like, is that a repeating signal because like a planet's going around a star kind of funny, like every few Earth years kind of repeating? This one was actually repeating like almost every Earth day. And it happened roughly around noon. And they kept on getting it, and they were like, this is really neat. Like, what could this be? And it turns out it was the microwave in the break room. So during lunchtime, when someone was heating their like frozen, I don't know, like frozen burritos, that was actually to give you a sense like how sensitive these machines are. They were picking up that. Um, so, but we have never found, as far as we know, any kind of alien life out there. But we were constantly listening, and then maybe one day. So maybe it could be a nice tourist destination for you. All right, that's probably long enough for my screencast today. Um, and we'll continue this discussion another day. I have a little activity for you to go ahead and do. So hopefully you enjoy, and hopefully you survive on the moon. And we'll see how you did. All right, have a great afternoon. Goodbye.